All right, I'm sure you're about tired of the Mr. Demien video series, but things are not getting better here at home. So we're going to go over yesterday's assignment from pages Indiana 31 to Indiana 34, numbers 1 to 23. You can try to do that fairly quickly, as hopefully you found the fundamental counting principle to make a lot of sense. And if you didn't, well, we'll condense it so you can see. If you look at number 1, it wants to know the total number of outcomes. You don't have to list them. You can make a list, but we taught you the counting principles. So you don't have to take all that time. So there's 4 types of bagels, 3 types of cream cheese. 4 times 3 is 12. There's 12 possible um, outcomes. If you doubt me, make a list. The next one, there's 5 choices of sandwich and 4 choices of side. 5 times 4 is 20. Picking a month of the year, a month, there's 12 months. And a day, there's 7 days in a week. 12 times 7 is 84. And choosing from a comedy, horror, action movie, that's 3 choices of movies, shown in 4 different theaters. So you can see right there, 4 different theaters. So 3 times 4 is 12. Okay. Number 5, it says find the number of possible routes from Eastland to Johnson that pass through Harping. Then find the probability that State and Fairview will be used if a route is selected at random. State the probability as a fraction and a percent. So from Eastland to Harping, there's 2 roads, State and Broadway. Then from Harping, you get there, you got 3 ways to get to Johnstown, Maine, Fairview, or Park. So 2 times 3 is 6. There's 6 possible routes. Now, how many ways could I use State? Well, State's 1 road, so that's 1 choice. And then Fairview, that's 1 choice here. 1 times 1 is 1. So 1 out of 6. Now, for those of you who still don't know, shame on you if you don't, to turn a fraction into a percent, a fraction's a division problem. So all you're going to do is divide 1 by 6, and you'll get this. I'm making fun of the writing. 0.166666666 repeating. That's a decimal. Move the decimal back 2 spots. You get about 16.7%. They round it to the nearest percent. 17%. That's fine. 16 2/3% would work too. Here's one to think about. Find the number of possible choices for a 2-digit number that is greater than 19. That means the number goes from 20 to 99. You don't need to count all those numbers. I mean, you could. But how many single digits are there from 0 to 9? And if you're saying 9 right now, you're wrong because you got to count 0, so there's 10. So there's 10 choices for the ones place. Then from 2 to 9, and you have to count 2 as a choice because it could be in the 20s. 2, 3, 4, 5, 6, 7, 8, 9. There's 8. 8 times 10 is 80. Find the number of possible choices for a 4-digit PIN number. If you can't repeat the digits, well, like we said, from 0 to 9, there's 10 digits. You pick a digit. You can't use it again. Now there's 9 to choose from. Pick one. Can't use that one again. Now there's 8 left. Pick one. Can't use that again. Now there's 7. 10 times 9 times 8 times 7 is 5,040. That's why they keep making passwords longer, because there's more possible choices or less likely to be guessed. An electronics company makes educational apps for 5 subjects, including math. The app has 10 versions with a different avatar in each version. One version has an avatar that looks similar to a lion. The company is randomly giving free apps to its customers. Find the probability of randomly receiving a math app with a lion avatar. How likely is the probability of receiving this app at random? Well, there's 5 subjects times 10 versions. It's 50. Now, there's only one way it can be a math app and have the lion avatar. 1 out of 10, 1 out of 5. 1 times 1 is 1. It's 1 over 50. And that, if you make it a percent, is 2%. To make you understand, 1 over 50 is very close to 0, so it's very unlikely, highly unlikely, that you're going to randomly get the math app with a lion avatar. All right. Next one. Sandwich shop offers 4 different meats, 2 different cheeses. Suppose they offer 24 different meat and cheese sandwiches. How many different breads do they have? Well, choice is 4 times 2 is 8 times something is 24. That something would be 3, so 3 different breads. A store offers 32 different t-shirt designs and 11 choices of its color. Is this a true ad? 32 designs, 11 colors. Multiply those together, you get 352, but there's 365 days in a year, so that is false advertising. Call the lawyers. Just kidding. Now, this is very interesting. Determine the number of possible outcomes when you flip 1 coin, 2 coins, 3 coins. Then determine the number of possible outcomes for tossing n coins. That means any number. Describe the strategy used. Well, think about it. If you flip 1 coin, there's 2 things that can happen. Heads or tails. If you flip 2 coins, there's 2 choices, heads or tails, on both. 2 times 2 is 4. If you flip 3 coins, heads or tails on each coin. 2 times 2 times 2 is 8. So, for any number of flips, it's just 2 to the number of coins power. 2 to the n power. So it said, here's a sample answer. It determined the number of outcomes for n coins. 1 coin, 2 to the first, that's 2. 2 coins, 2 to the second, that's 4. 3 coins, 2 to the third. N coins, 2 to the nth outcomes. So if I wanted to flip 10 coins, how many different outcomes would I have? All you'd have to do is take 2 to the 10th power. You can do that on your calculator. There's 1,024 different outcomes because you're keeping track of all of them. Now, you might not believe it, but would you like to make a tree diagram for that? Neither would I. That's why we learned the counting principle. Which of these doesn't belong? Well, 9 drinks, 8 desserts, that's 72 outcomes. 18 shirts, 4 pants, 72 outcomes. 10 groups, 8 activities, 80. Bye. Doesn't belong. Marcus has a choice of white, gray, or black shirt to wear with a choice of tan, black, brown, or denim pants. Without calculating the number of possible outcomes, how many more outfits can he make if he buys a green shirt? That'd be 1 more shirt. How many colors of pants does he have to wear with that shirt? 4. So 1 times 4 is 4 more outfits. Okay? He's a guy. He's not worried if it matches. That's how we roll. Okay? Write an algebraic expression to find the number of outcomes if a number cube is rolled 6 times. Pardon me, is rolled X times. This is just like flipping the coin. When you roll 1 die, there's 6 different numbers on it. So there's 6 different outcomes. Remember yesterday? We rolled 2 dice. 6 times 6, okay, which is 6 to the second. That's 2 dice. Told us there was 36 different rolls. So just like before, if you're rolling dice, let's talk about Yahtzee. How many dice in Yahtzee? 5. To get Yahtzee, they all have to match. So you multiply 6 to the 5th power, 5 dice. So there you go. However many dice, it's 6 to the number of dice power. That's the answer. That's how many different outcomes there are. All right, we're back to this. 14's done for us. Tossing a coin, 2. Selecting 1 letter from the word math, 4 choices. 2 times 4 is 8. 1 sweatshirt from a choice of 5 sweatshirts, and 1 pair of pants from a choice of 4 pairs of pants. 5 times 4, there's 20 possible outfits. Selecting 1 entree from a choice of 9 entrees, and 1 dessert from a choice of 3 desserts. 9 times 3, 27 outcomes. Rolling a die, and tossing 2 coins. 6 numbers on a die. Whoops. Each coin has 2 sides. 6 times 2 times 2 is 24. Choosing a tea in regular, raspberry, and lemon, or peach, that's 4. Sweetened or unsweetened, that's 2. In glass or a bottle. In a glass or a bottle, that's 2. 4 times 2 times 2 is 16. Okay. Cafeteria offers oranges, apples, and bananas as its fruit option. It offers peas, green beans, and carrots as the vegetable. Find the number of fruits and vegetable options. So there's 3 choices in each. 3 times 3 is 9. Find the number of fruit. If the fruit and the vegetable are chosen at random, what's the probability of getting an orange and carrots? 1 way to get an orange, 1 way to get a carrot. 1 times 1 is 1. It's about 1/9, or about 11.1% unlikely. Okay, it's closer to 0 than it is to 1. Alright, this table shows cell phone options. Remember when you had all those offered by a wireless phone company? If a phone with one payment plan and one accessory is given away at random, predict the probability that it will be brand B and have a headset explain your answer. Well, 3 choices of phone, 3 choices of brand, 4 choices of plan, 4 choices of travel charges, capital C, 4 choices of accessory. 3 times 4 times 4 is 48. They want to know it's going to be brand B and have a headset. Well, that's one type. That's one type. 1 times 1 is 1. But you can have any payment plan. 1, 2, 3, 4. So 1 times 4 times 1 is 4. So 4 out of 48 or 1/12. That's how they found it. Counting principle. Making hard work much easier to deal with. A restaurant has 24 different lunch combinations. Which of the following could describe the lunch options? Select all that apply. Pick the ones that multiply out to 24. And then Hat Shack sells 9 different styles of hats in several different colors for 2 sports teams. The company makes 180 different kinds of hats in all. Select the correct values to complete the formula below to find the number of different colored hats. Well, 9 styles times C for colors times 2 is 108. 9 times 2 is 18. Divide 108 by 18, there's 6 colors of hats. All right. Now, ladies and gentlemen, let's turn to page 702 in our books, and we're going to take a look at descriptive statistics. Now, you may remember some of these measures of central tendency and variability, but so far for the last few months, all the data we've been studying has been bivariate data. Bi meaning 2, like bicycle has 2 wheels. Bivariate, 2 variables. Slope, proportional relationships, non-proportional relationships, functions. That's 2 variables. Now, this is going to take us back down memory lane to data with 1 variable, like test scores. They're called univariate, like unicycle, 1 wheel, univariate, 1 variable, univariate data. Now, this data can be described by measures of center. Measures of center, formerly known as measures of central tendency. When I was in school, they called them averages. But here you go. The ages and years of the people seated in one row of a movie theater, 16, 15, 24, 33, 30, 56, 19, and 19. Find the mean, median, mode, and range of the data set. Mean. That's the first thing you learned how to do back in elementary school. The average, the arithmetic mean. Add up all the numbers in the list. Divide by the number of items in the list. 212 divided by 8 is 26.5. That's the mean. The median. That's the middle term. It may or may not be in your list. To find the median, you must put the numbers in numerical order. From least to greatest is usually how it's done. Now, usually many students will take their fingers and start on the outsides, crossing off numbers or covering them up till they get to the middle. You're in 8th grade. You're going to high school. I'm going to make it easier for you. Remember with median, you have to pay attention. Is there an even amount of numbers in the list or an odd? We said there were 8. So you want something that's right in the middle and splits this list. It's not about the values, it's about how many numbers are on each side. So if you look, 8, what's half of 8? Well, that's 4. So if I go in 4 spots, 1, 2, 3, 4, I'm right here. But if I'm right here, there's 3 numbers below it, 4 numbers above it. That's not right in the middle. I shouldn't go to 5 because 5 is not half of 8. No, you shouldn't. But anytime you have an even number of data, you use the 2 middle terms. Since 8 is even, when we go in here to do the median, we're going to go to the 4th and 5th number. Okay? To find the number between them, you average them together. You add 19 and 24 and divide it by 2. Now you might be saying, wait a minute, Mr. Demien, the median's not in the list. You're right. The median's not in the list. It's 21.5. And it would be right here in the middle where I just put that line. But now, how many numbers are on the left side of the line? 4. How many numbers are on the right side of the line? 4. So the median separated the list into 2 equal parts, equal by the amount of numbers on each side. The mode is the number that occurs most. There can be more than one mode. There doesn't have to be a mode. If everything occurs the same amount of times, there is no mode. But in this case, if you look, and this is much easier to see when they're in order, there's two 19s and there's nothing else. So the mode is 19 since it's the number that occurs most often. And then the range is pretty straightforward. Range is just how spread out is the data. So it's the high number minus the low number. So 56 minus 15 is 41, and that's the range. Okay? So now, if we go a little further down, they give us one to practice on. Okay? So take a look a little further down. Looks like this. Find the mean, median, mode, and range of this set of data. Now you could, the heights of students in inches, you could add all these together and divide, but you know you got to do median, and you're going to have to look for mode, so you might as well put them in order. Luckily for you, bam, they're in order. Okay? And I can tell 3 by 5, there's 15 numbers in this set. So to do the mean, I'm going to add up every number in that list. Okay? So I got 60 plus 62 plus 64. You guys can do this with me on your calculator. Plus 65 plus 66 plus 66 plus 67 plus 68 plus 70 plus 70 plus 71 plus 72 plus 72 plus 73 plus 74 equals 1020. Okay, so I've got 1020. Now that's not the mean, that's the total, but I have to divide it by the number of items in the list, which is 15. So I'm going to divide 1020 by 15, and the mean is 68. Okay? So the mean is 68. Now, we know there's 15 items here. That's an odd number, so there's only going to be one number in the middle. Again, you could sit there and cross them off back and forth. That's kind of elementary school. So what's half of 15? Well, that's 7.5. Round to the nearest whole number. Well, that rounds up to 8. So count to the 8th number. 1, 2, 3, 4, 5, 6, 7, 8. There's my median. There's 1, 2, 3, 4, 5, 6, 7 numbers below it. 1, 2, 3, 4, 5, 6, 7 numbers above it. So the median and the mean are both 68. The mode, well, do you see any number more than any others? Let's use the highlighter. I see 266s, 270s, and 272s. And I got nothing else more than once. So in this case, there are 3 modes. 56, 70, and 72. And then the range, well, like we said before, that's just the high, 74 minus the low, 60 equals 14. Mean, median, mode, range. There you go. Easy peasy. Now, we're going to take that a step further because they talk about something called the 5-number summary. It's right down the page. Quantitative data are data that can be measured. A set of quantitative data can be divided into 4 equal parts called quartiles, hence the root word there. Quart meaning 4 sections. Now, if you'll notice, they got a list of numbers. Don't know where they came from, but they have them. They put them in order. If we put them in order, you know what we're going to do. We're going to split them in half with the median. Now there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers in this list. That's even. So half of 14 is 7. Because it's even, we need the 2 middle numbers. Okay. So we're going to basically need these 2. The question is, what's between 36 and 38? Okay. And if you add them up and divide by 2, or if you just know 37 is between let's move that. median's 37. It's not in your list, but that's your median. Now, what did it do? It divided your list into a lower half. These numbers are all lower than the median. These numbers are all greater than your median, so that's the upper half. So now you're going to split these lists into two equal parts. So you're going to find the median for the lower half and the median for the upper half. Now, to avoid confusion, because I said median, 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 median a bunch of times, you just go to this list, you go 1, 2, 3, 4, 5, 6, 7. So half of 7 is 3.5, rounds up to 4. 1, 2, 3, 4. Okay, well, we've found what is called, whoops, the first quartile. Okay, the first quartile, in this case, it's 31, because look, let's use the line thing before. It broke this smaller list into 1, 2, 3, 1, 2, 3, 2 equal portions. Okay, third quartile, well, you go to the upper half, 7, same amount on each side, so 1, 2, 3, fourth number right here. Okay, it's 45. Okay, now the low number, well, that's just the low number in the list. What's the low number in the list? Well, 24. What's the high number in the list? 54. That's the 5-number summary. It includes the minimum value, the lowest, quartile, the first quartile, 31, the median, third quartile, and the maximum value. They go in order that way, but when we find them, we start with the median. That splits the list in half. Then we split each other one in half. Then the low, then the high. Okay? This is called a box plot. It used to be called a box and whisker plot. Notice, you take a number line. You put dots. For the median, it's 37. Look, it's right above 36 and 38. First quartile, put a dot there. Third quartile, 45, put a dot there. High, 54. Low, 24. You create a box around the first quartile and the third quartile. You make this box and align it there with the median. What it shows you is how spread out the numbers are. Up here, we don't care about their values. They just have to be in order. There's 3 numbers in each section. But here, when you use a number line, it talks about the values of those 3 numbers. From 24 to 28 is 4. From 35 to 36 is 1. Or pardon me, from 31 to 36 is 5. From 24 to 31 is 7. Okay. From 37 to 45 is 8. From 45 to 54 is 9. Now, one other thing over here on the side, you see this passed into your book. If an asterisk appears on a box plot, it represents an outlier. Outliers are data that are more than 1.5 times the interquartile range from the first and third quartiles. Okay? So, 1.5 times the interquartile. What's the interquartile range? The interquartile range is just this. Let me type that in there. Ooh, that's too big. That's the third quartile minus the first quartile. Okay? Sorry, I had to deal with the puppy dog. So back to the outliers. The interquartile range is the third quartile minus the first quartile, which would be 45 minus 31, which is 14. Multiply that by 1.5 and 21. So you take the first quartile, 31, subtract the 21. If you have anything lower than 10, it's an outlier. Or you take the 21 and you add it to the third quartile, 45, and you get 66. So anything higher than 66 would be an outlier. And as you can see, there are no outliers because 24, the low number, is bigger than 10, and 54, the high number, is lower than 66. All right, so let's go over here to 704 and take a look at this. The points scored by a basketball team are shown in the table. Give the 5-number summary of the data. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. They're in order. So half of 9 is 4.5. Rounds up to 5. 1, 2, 3, 4, 5. So different colors. Here's our median. Median's 36. Okay. And then there's 1, 2, 3, 4 numbers in this one, so you gotta go between the two. So between 34 and 35, you get 34.5. So that's our third quartile. And over here, same thing. Between 40 and 42, 40 and 44, 40 plus 44 is 84 divided by 2 is 42. So far, okay, we've got 36 for median, 34.5 for the first quartile, 42 for the third quartile. The low number is 20. The high number is 83. Are there outliers? Well, we got to find that interquartile range. So 42 minus 34.5. So we got to come down here and do 42 minus 34.5, which equals 7.5. And then we're going to multiply 7.5 times 1.5. And see what we get there. $11.25. So now, go to your quartiles, subtract 11.25 from 34.5, so your first quartile minus that. Okay. Here are the low outliers. 4.5 minus 11.25 equals 23.25. Do we have anything lower than that? Yes, we do. 20 is an outlier. Okay. And then we go to our third quartile, 42, and we add the 11.25, which equals, 53.25. Do we have anything bigger than that? Yes, we do. 83. So, over 83, we would put an asterisk. So we go up here. Let me get this set up real quick. Okay. I'm going to put some dots in here. Alright, I'm going to try to go up above it. That's not going to be easy. Let's just do this freehand. Go with a pen. So over 83, which is a little bit past here, you're going to have an asterisk. And 20 is going to have an asterisk. Now, your first quartile is 34.5. Put a line there. Your median's 36. Put a line there. 42. Put a line there. There's your box plot. We're not extending whiskers out because these are outliers. Intentionally, we go back to the next one. So that's it. That's all we have for our box plot. And I know this took a little longer than normal, so all I'm going to have you do, 5 problems on page 705, 706. Guys, have a great day. Hope to see you on Thursday.